Welcome back, everybody. It is Wednesday, my dudes. I'm a big old frog or something. I don't know. Memes didn't used to be videos. Back in my day, we had animal-themed memes that were just pictures that you guys probably don't think are funny, and I don't know if they were really funny then, but they still make me laugh. Tomorrow at the start of class, I have a challenge. I want you to bring me your favorite meme right now. Favorite school-appropriate meme. And before class, I want to see them. Are all your memes videos?
Yeah.
Okay, bring me school appropriate memes. Find them on TikTok, save them. I don't know how you do that, but I want to see some sweet, dank memes tomorrow. Cool. All right. So, here we go. Today, we are starting 3.3, and I promise we are not going to have homework today. I'm going to think out this other decision in my head as we go, but we're going to be talking about Tom Petty lyrics. Or, if you'd rather, Free Fall. That joke probably didn't land with anybody, but it was a good one, I promise. Now, when you think of famous, I don't know, you probably don't think of this person as a physicist right off the top of your head. You can probably name a couple physicists, at least. Name one. Albert Einstein, he's a big one. Is that yours? Ooh, you probably, maybe you watched a movie that I thought was actually kind of terrible. The physicist that helped develop the nuclear weapons. Oppenheimer was a famous guy. They were all alive at the same time, right? That was the 20s through the 50s. Oppenheimer was a little bit past Einstein. Can you name any others? Newton was a big one. About the same time as Newton, there were other people going on. If I say the name Galileo Galilei, do you know who I'm talking about? It was not Greek. You do know? Maybe not now that I said he's not Greek. He was an Italian during the Renaissance era. I think of him with sailing more than anything. Galileo Magellan, I think of those guys as sailing the seas. But if you're going to sail the seas and you're going to be wayfaring, which is the only way you could do it without GPS, you needed to have an understanding of how everything moved, right? So what study might tell us how everything moves and to be able to predict it and use the stars as our guide? Formal academic study that how everything moves all the time. Physics. It's physics, right? Like we're physics. Okay. So check it out. We are going to do this tomorrow, pending the fact that I can find all the stuff to make us do this tomorrow. We're going to see what Galileo Galilei. So I'm going to misspell his name if I don't look. Galileo Galilei. We're going to be looking at his discovery. Okay, Galileo, pretty big guy. He had this brilliant discovery that he noticed regarding free fall. So right off the bat, we're going to define free fall for ourselves. And in my mind, I want this to be one word. I'm going to double check to make sure it's not. It's not. We're going to define free fall. And we'll make it vocab. Now, you there's not many times that it works perfectly. You probably have a good idea of what this is. What does it mean to say an object is freely falling? Meaning what? Give me an example of a free falling object. Okay, you're close. You're real close. You're right. You're not entirely right, though. Now, when we say free falling, there's an issue that I have with that, and it's only a minor issue. Here's a piece of paper. It free falls. But something pushes against it. Air. There's friction with the air, right? There's air resistance. Luckily for us, we don't have to do a ton of math with air resistance because it gets harder. But we're going to say that free fall, by definition, is going to be the motion of a falling object whether it be that piece of paper or an egg, whatever it is, the motion of a falling object where the only force acting on it is, and I'm going to pause here, what pulled that paper down to the ground? Gravity. Easy. Cool. Gravity. Now, with this, I'm going to leave a part of this blank here for a moment because I don't want to give away the answer for a little discovery thing tomorrow. But we're talking about free fall. If I have this piece of paper and I drop it, it's going to reach its max speed, but it's not going to be super fast, right? If I dropped that and a marble at the same time, what hits first? Why? Yeah, 100% that. It's aerodynamic, right? The air resistance doesn't stop it. What if we were to work in a vacuum chamber, which I don't know if we talked about it in here. Did we watch a video? What happens in a vacuum chamber? They both fall how? Same speed, same time. Does the mass matter? No. The 5 feathers, I think, from that video, way different than a bowling ball, but they fall at the same speed. Now, when there's no air, the only force acting on it is what? Gravity, no resistance, doesn't matter about the mass. Now, with that, if we let an object fall, let's say we're in a big vacuum chamber and somehow we don't die because we're in a big vacuum chamber, and I'm going to say I'm going to drop a bowling ball on you. And I give you 2 options. I'm going to drop it either from a foot above you or 10 feet above you. Which do you choose? Well, that's dark. Okay, you don't get to move. You obviously want the foot. Like, probably don't want either, realistically. But it'd feel better to get hit from 1 foot drop than a 10-foot drop, right? Now, why? It doesn't really matter about the mass. It doesn't matter what the object is. Do objects speed up? Oh, love it. I don't know if that's necessarily less. Love most of it. Less time for that object to accelerate through. Now, it turns out, free-falling objects, and this feels super redundant, but I'm going to write it. You can shorten this if you want. We're going to define free fall acceleration. And I don't know that we really need to define it, but I'm already this far committed, so we're going to do it. Free fall acceleration. Now, as we go through with this, I want to specify we're in a vacuum, or more simply put, no air. We don't have to deal with friction and air, which makes this significantly easier. It turns out that the mass and shape of an object, completely irrelevant. The mass and shape, as long as we have no air, are irrelevant. Now, we'll be more specific. We'll say for acceleration, and I'm going to use my shorthand for it, acceleration A due to gravity. Now, this is a weird idea. And the fact that somebody had this idea 600 years ago, 500 years ago, is pretty crazy. They didn't get to truly confirm this until astronauts were on the moon, allegedly. Okay. So as we go through here, no smiles from anybody at that. Here we go. As we look at it, I'm going to make an asterisk here, but I'm not going to give you the number. But we're going to write all this stuff, and then we're going to find the number tomorrow. Roughly. We'll see what we get. Okay. So near Earth. Near Earth, which, because we're talking about the planet and not like dirt, it's a capital E. Near Earth, free fall acceleration, which is due to what force? Good. Gravity is quietly whispered confidently by Angel. Maybe over here as well. Near Earth, free fall acceleration is, and there's a few different ways we can write this. We can write this as the acceleration due to gravity, A sub g, lowercase g specifically, or if you guys would rather, and I'm sure I'll use both just interchangeably, just say capital G. Sorry, a lowercase g, no subscripts. We can either call it acceleration sub gravity or just call it gravity, and we'll imply that we're talking about the same thing. This is equal to some number that we're going to find tomorrow. So just so you know, I'm going to have some number in meters per second squared. We're going to have this other version in miles per hour. Do you want to write mph or m/h? I'm going to use this, and only because if I write m/h, it looks like meters per hour. Okay, the last one that we'll get it in is feet per second, with the understanding that these units are awful. And there's one last wonky thing. And this is where we're going to leave off today. We're going to have a couple minutes to chill. If I drop an object, it falls which direction? Okay. Could you say negative depending on your perspective? Could you say positive depending on your perspective? So instead of classifying this as positive or negative, I think it's more meaningful to just say downward. All right. Anybody in here afraid of flying? I hate it. Hate it. I hate driving as a passenger. I hate flying as a passenger. What's the worst case scenario that happens if the plane doesn't work? You crash. You might have a crash landing. My hope, and this is going to sound really dark, if I'm ever in a catastrophic plane accident, I don't want it to be one where we slowly glide down and have to crash land. I want it to be where the plane rips up, just stops, something, I don't know what, and it falls straight down.